This is 8F4 8th grade functions for video 1, modeling with functions. Looking at the standard, we are going to be doing a couple of things. The first thing is determining the rate of change and the initial value of a function given a description of a relationship from two xy values on a table or a graph. All right, so this is a very long standard here. Additionally, we are going to now interpret the same information, the rate of change and the initial value of the function in terms of its situation. So we are determining and interpreting rates of changes and initial values on a table and a graph. That is a very long standard, and my job right now is to take this standard and explain exactly what it's talking about. Here are a few terms I'd like you to know. Please write them down and define them in your journals. Use the linear relationship shown in the table to complete the exercises. The exercises are going to be 3 questions. This is the first question of 3. And looking at the data, it says, determine the rate of change. Now we have described the rate of change as being the change in the y-axis over the change in the x-axis. Also called the rise over the run, also called the slope of a line. Now, looking at this table of values, if I am looking at the 200 value and we move on to 350, that is an increase of 150. Then I'm going from 350 to 500. That is also an increase of 150. So the change in our y-axis is an increase of 150, and they're talking about dollars in terms of a profit. For the run, we have an increase of, it appears to be 200, and that from 400 to 600, and then from 600 to 800, it is also a change of or increase of 200. And we have a constant rate of change. That helps. Knowing that it's a constant rate of change, it is going to create this linear relationship. All right, now this is going to take different forms. There actually could be multiple answers to this rate of change. I can cross out the zeros and have a rate of change of 15 over 20. That is also a fraction that can be reduced to 3/4. And 3/4, if I were to create a unit rate out of this, I would turn it into a decimal and say I have 75 hundredths, because 3 divided by 4 is equal to a decimal of 75 hundredths, and that would be per 1. All right, so we've determined the rate of change as being any one of these options. Best option, I would say, would be 3/4 or this 75 hundredths. And what that means is the selling price of each of the flowers. So looking at the table, I have the number of flowers sold and the profit in dollars. So what it means in context is that I have 75 cents being the selling price of each flower. All right, question 2. Now we're going to take the same table and determine the initial value. And I equate the initial value to the initials of your name. So if I were to say, what are the initials of your name, you would give me the first letter in each part of your name. Kind of the same idea when they're talking about that in this table. So the initial is the starting point, and the starting point would be your 0. And I don't have a 0 in my table, but I can use some techniques to figure out what my 0 would be. We always start from a 0 point when we're talking about the initial value. So working our way backward, if we are now increasing by 200, we can decrease by 200 to find our starting point. So 8, 6, 4, 200, and then 0. Looking at my outputs, my profits, if I'm following the same pattern of deducting $150, I'm going to end up with 50 and a negative 100, because 50 take away 150 is going to get us into this negative value here. Okay, so it says determine the initial value. Our initial value is negative 100, and explaining it in terms of the context, it says if 0 flowers are sold, there would be a debt of $100. So this would be a debt of $100, or you're at negative $100. All right, the third part. Now, given this information, we need to construct a function to model this linear relationship. And function is that key word. This is a function table in which we have a relationship of our inputs and outputs. And since we have all of these inputs and outputs and a constant rate of change with an initial value, we can think back to our slope-intercept form. So this is function form of an equation, y equals mx plus b. All right, so y is equal to m, we've decided was 3/4 x, and our b, that's our initial value, that is at negative 100, a debt of $100. I can also accept the answer in decimal form. So we're at 75/100 x minus 100. And then, you had these other larger rates of changes that weren't simplified. They are acceptable in some sense. My preference is always the reduced form. Okay, the second part of the standard said we are going to take and extract this information from a graph. So we're going to determine rate of change in initial value and interpret them from a graph that we're going to look at. Okay, sharpen your skills. Mr. Wertz accidentally overdrew money from his savings account. He decides to deposit money for several months without making any withdrawals. The change in his balance over time is shown in the graph, and use the graph to complete those 3 questions, the exercises that I'm going to give you. All right, so just a little background information. Some of these words that I'd like you to know about. Overdrew. So if I'm going to overdraw something, I'm going to do too much. I'm going to be taking too much money out of my savings account. Your savings account has an initial amount, a starting amount, and if I were to write a check for an amount that is more than what I have, I overdrew. I took too much out. I went past 0. It's a big mistake. You really don't want to do that. And then I decide to deposit money. Deposit means to put money in. So since I made an error and I took more money out than I had, I now need to fix my error by depositing money. So I have a job, I get a paycheck, a portion of my paycheck is going to go into this account so that I can start building it up again. A withdrawal is taking money out. Now, I'm not going to be doing any withdrawals because I want to keep that money going into the account so that I can raise the amount of money so I don't make that same mistake when I want to go buy something. And then if I see the word balance, so balance means with all of the transactions that are going on, if I'm putting money in or depositing money in, I'm not going to be withdrawing. But what if I did? It would be the combination of the deposits and the withdrawals over time, and my doing the math to keep it up to date. It's a record keeping idea. So if you're balancing a checkbook, you are taking care of the additions and subtractions from the amount that's in the bank. Okay, so there's a little lowdown on some of the new terms that are in this problem. If you have any questions on that, please ask me in class. All right, so here's the graph. Our x-axis is the time in months. So if you're looking down here on the bottom, every one of these unit boxes are worth 1 month. And then on the y-axis, this is the balance. So this is the record keeping of our deposits. Now recall, I didn't take any money out, so I'm not doing any withdrawals. So these are all deposits in dollars. And notice down here on the bottom where my line is crossing the y-axis, my initial value is below 0. And that was the mistake that I made. I wrote a check for too much money, and there's a little penalty involved in that. I actually took out $25 more than I was supposed to, which is why I'm below 0 at -25. Now, over the next several months, from my paycheck, I was contributing a certain amount of money at a constant rate of change. I constantly added in the same amount, and my job is to find out how much money I put in per month. You know, as I climb along this red line, I am using a constant amount of money to create this straight line. And let's go figure out what that is. My rise over my run, my rate of change, is going to be the distance between my y values, so my difference of the y values, over the difference of my x values. All right, so if I went from -25 all the way up to 255, what kind of change? Well, 25 gets me to 0, and then another 255, that would get me to 280. And the change from, what are we at? In the x values, my x value is 0 months. So at 0 months, I started depositing money for 8 months. So my change in the x value is for 8 months. All right, another way of doing that, if you don't have the graph in front of you, you just have these ordered pairs. Let me quickly show you. It's the difference of your y values over the difference of your x values. And you would get the same answer of 280 over 8. Now let's simplify this. 280 divided by 8, I think it's about 35, or yeah, I think it's 35. Let's check it. So we have 280 divided by 8. It is. Okay, so we have a 35 dollar per 1 month rate of change. So 35 per 1 is our rate. And then what does that mean in terms of the context? All right, so 35 is the rate. And in terms of the context, that means this is what the savings account balance increases by each month. All right, so did you get that? The savings account balance increases every month by $35. So after month 1 was 35, after month 2 I took $35 out of my paycheck and I put it in, and I kept doing that for 8 months, and that got me up to this random $255 that I wanted to show you. And you can also predict what's going to happen after 10, 12, 14, 16 months. If you wanted to follow that red line off the grid, you can determine some of those values in the future. All right, question 2. It says determine the initial value. Okay, so where did we start at our 0? If I'm following all the way down, our initial value is at negative 25. And what does that mean in terms of its context? It says that the account had an initial balance of $25, an initial balance of negative $25, which is a debt of $25. Okay, function form. We know that we have y equals mx plus b. There are sample answers, a few answers that can go with this. I like the simplified form of y is equal to 35x and minus 25 if we were to go ahead and graph that equation. Okay, in your journals, I'd like you to define the given terms on page 2. And if you want to define those other terms from the word problem about a savings account, please do that. Write a few sentences on what you learned from the video. And more importantly, this part right here. If you have any questions, if you didn't understand something from this video, please write down those questions. We're going to begin the next class period by answering those. And I'll see you in class.